you actually press this button up here. So these are the 1D charts. These are the plan view charts. Okay, so with DESI, this is what I've been working on mostly since I've transitioned to GSL. And again, we're using WebGL, the fastest web graphics library available, to draw all these animations. And you can see everything is quite smooth, zooming in and out. It's running around 60 frames per second. So it should be smooth on your computer. And we're actually transferring the data to your computer. We're drawing all these images on your computer using your GPU. And that's why we're able to achieve this performance. But anyways, with the plan view charts, they're kind of set up the same as the point view. You can change the runtime. As we get different data sets, you could change the data set there. You can group by, ensemble, or cluster. We'll go over clustering in a second. And we have this new select box here where it says Grand Ensemble. That's what you're looking at. But if you wanted to look at the European, you can change that select box to the European or the GEFS, whatever you'd like. But let's just keep it on the Grand Ensemble. And then I have these options here, which I call widgets. Okay, so if you hear me say widgets, I'm just talking about these fields here. So we're looking at the Grand Ensemble. If I wanted to look at the minimum value from the Grand Ensemble, I press that min button. And it goes to the back end. It opens all 100 files. It calculates the minimum of those 100 members and returns it to you in about 2 seconds. And if you think 2 seconds is too slow, I think I agree with you. And we're going to try to make that even faster. So that's on the books of things to do. But if you wanted to just view a percentile, let's say the 25th percentile of this Grand Ensemble, you'd press the 25th button, it'd go to the server, does the calculation, returns the data to you. So pretty cool. With DESI, you can go forward and backwards in time, of course, with the slider, or you can use the arrow buttons on your computer. If you'd like to play the animation, there's this play button. And what's happening when you press play, it actually interpolates between time steps in real time on your computer. So I don't know if this is desirable or what, but it sure kind of makes a pretty picture. So if we want that changed, let us know. We can change it. And if you want to speed up the animation, you press the plus buttons, and you want to slow it down, you press the minus buttons. So that's kind of the time controls there. With DESI, we got multiple maps here. Let's say for some reason you don't like the countries and you want to turn them off, you can absolutely do that. If you want county lines on or off, you can, or CWAs. And these are just shape files. So if there's a shape file, you're thinking, man, it would really be helpful if this shape file was in DESI. We can absolutely add it. So let us know. And then I should mention with DESI, we not only have this three-dimensional globe look, we also have more of a 2D Google Maps view here. And so if you press the shift button, you can change the bearing, the pitch of the data set and really look at it however you'd like. I'm going to switch back to the globe look. Okay, and then I just kind of wanted to focus on the different variables that we have here. We have some upper levels, precipitation, convective, and surface fields. We are missing some important variables like wind gusts and snowfall. And I wish we had it, but the only reason we don't have it is because we don't have the data. And if we had the data, it would be in DESI. But let's just set that aside for a minute. And I just want to walk through some variables real quick. So under here for cloud cover, if I press statistics, that's how you're going to get this widget over here with the min, the max, the mean, and the percentiles. But if you press the ranges button, so I'm going to do that for 2 meter temperatures, press ranges. Ranges is essentially taking the differences in percentiles. So let's say you want to look at the 90th percentile minus the 10th percentile. You would press the ranges button. Or you want to look at the 75th minus the 25th. You can go over here to this widget area and press that. So this kind of represents, if you're used to looking at the box whisker plots on the 1D viewer, this is essentially what you're looking at. You're looking at the top box value minus the bottom box value. So it tells you how much uncertainty there is in the forecast. And I'm not sure how helpful it will be, but that's kind of why we're trying all this out. But I can see right here, I'm looking at Friday, 5 a.m., May 20th. There's a lot of uncertainty in the temperatures with this front coming through, okay? And that would be kind of what you would expect with a front. And so it may be helpful in that sense of really identifying those areas that, hey, we're really uncertain in the temperatures for this particular period, or any sort of variable you want to view the ranges on. So you can do that. Okay, and then last but not least, I want to show you the clustering on these plan view maps. So I'm going to go ahead and press this group by cluster button, which we already did with the point view charts, right? It goes through that code, does the principal components analysis on the 500 milliball heights, and it returns all these different clusters to you. Okay, so right now I'm looking at the grand ensemble, which is the select box. But if I wanted to look at cluster 1 and the temperatures for cluster 1, I just change it with the select box, or cluster 2, or cluster 3, or whatever. So I'm going to switch back to the grand ensemble. I'm going to show you this button up here. And what essentially this button does, it decomposes the grand ensemble into its parts. So I'm going to press it. And we know the grand ensemble is made up of cluster 1, cluster 2, cluster 3, cluster 4, and of course the grand ensemble. So that's the way you're able to toggle from this one display to this multi-panel display. So now what I'm looking at the temperatures of the clusters. And remember, we kind of identified already that cluster 3 and cluster 4 are cooler for the Salt Lake City area. And so I can hover my mouse over it and I can get a readout, and that's kind of cool, but it's really kind of hard for me to see the differences. So we added this A-B button up here, and that essentially takes the difference from the grand ensemble. So what this is showing me is that cluster 1 has these red values, which means it's warmer than the grand ensemble, and clusters 3 and cluster 4 are actually cooler than the grand ensemble. And that's all what we saw on the point graphs. And so this is just another way to view the data. So let me go back. And last but not least, I want to show you the plots that you find on the WPC website, the EOF patterns and the phase spaces. They are still here in DESI. So under the upper levels, since we are clustering on the 500 millibar heights, you can look at the EOF patterns of the 500 millibar heights for the particular day that you are clustering on. And you can animate it just like you can before. And you can also look at the phase spaces. So you go ahead and press on that. We're clustering on day 7, but if you can cluster on day 6, you actually get these pretty cool animations of how the phase space plots update for different clustering days. So I think that is it that I wanted to show on the plan view charts, but I have a few slides just to finish up. So I'm going to switch back over to my PowerPoint.